Okay, so for the next part, we're going to talk about interval notation. So, interval notation, we're just going to talk about set builder. We're going to look at some examples and see if we can figure out the interval. So, for the first one, set builder, this is just a kind of specific one for part A. How this works is if it is a parenthesis, these are open, meaning they do not include the value on the end. So I'll explain more in detail in a second. And then if they have a bracket, they are closed, meaning they do include the end points. So since it doesn't express what variable we're using, we're going to say x such that. So it says they want it between -1 and 4. So -1 is not included, so strictly greater than -1, but less than or equal to 4. Okay, so that would be your set builder notation. We're going to do this again. We have the set such that x such that 2.5 is less than or equal to x, which is less than or equal to 4. Sorry, that bracket's ugly. My right ones are always wrong. And then finally, -4 to infinity. Oops. We have x such that -4 is strictly less than x, which is less than infinity. Okay, and that is your set builder notation for all of these. Now, we're going to explain intersection and statements. There's a reason for this. If we have x is equal to the set of numbers 1, 2, 3, 4, 5, and y is equal to 1, 3, and 6, then what's in the intersection? So we write x intersect y. We want to know what intersects these two sets. Well, those are the values that are in both sets. So 1 is in both sets, 3 is in both sets, and that's it. So therefore, 1 and 3 are in the intersection of x and y. And those intersections are considered and statements. So let's do the intersection of two sets. Part A, 1, 4 included, or I'm sorry, open, 2 through 8. And what I'm going to do in this example, I'm going to draw, I'm going to draw a number line. So over here we have 0. Here's 1, 2, oops, I didn't mean to write that there, 5, 6, 7, and 8. Okay, so the first interval is 1 through 4, so we're just going to draw parentheses here, 1 through 4. Okay, and now let's do 2 through 8. Well, 2 through 8 is going to include 2, and it's going to include up to 8. Okay, now we want to know what's in the intersection of these two. So the red one is the first interval, the blue one is the second interval. And so where do they intersect? Well, that would be right in here. Okay, it'd be nothing outside of that because anything over here doesn't have any blue and anything over here doesn't have any red in it. And so what interval is that brown thing? That brown thing is from 2 up until 4. And 4 is not included because 4 is not included in this set. It has to be something you can choose from both sets. So for instance, if I choose 1.5, 1.5 works here, but it does not work here. If I choose 7, 7 works here, but not here on this side. And so if I choose 2.5, well, you'll notice that that falls in this range and this one. And so we can use 2.5. And so that's how and statements work. Intersections are things that fall in both sets. Has to be in both or else it can't be used. So now we're going to talk about unions. And so if we look at this, notice that we have 1, 2, 3, 4, 5, 1, 3, and 6 again. So if we want union, we want anything that's in both sets. So notice that 1, 2, 3, 4, and 5 are in X, and then the only thing to be added is 6, because 6 is the only thing different in Y. And so the union of the two is 1, 2, 3, 4, 5, 6. Okay, so now let's look at unions of this. So we've got 1 through 4, union with 2 and 8. So if we go and look at the picture again, remember I had 1 here, I had a bracket. Over here somewhere is 4, I had a bracket. Somewhere over here is 2, I'm not a bracket, I'm sorry, a parenthesis. And somewhere over here is 8, and I had a bracket. Now we want it to include everything, so what that means is we don't need the overlap. This all the way to here. So we start at 1. Okay. If it's in either set, then it's good to go. Well, 1 is not in the set, but it's open at 1, so that's fine. That's good. We'll get 1 through 0.5 in here. We can use 4 in this case because 4 belongs to this set, but not to this one, and it's okay as long as it belongs to 1, you can use it. So 4 works, so we don't have to stop here. And then we go all the way to 8, and 8 is where it ends, and 8 is included, and therefore we use 8 with a bracket. Now, if you wanted to test if we've found everything in the union, you could kind of ask yourself, is 1.5 in this? And the answer is yes, because if 1.5 is here, then it doesn't matter that it's not here. If you say 7, 7 is here, but it's not here, and for the same reasoning, 7 is included because it doesn't matter because this is a union instead of a... This is union. This is intersect. The way unions work is unions are or statements. Or statements, only one thing has to be true in order for it to be true. And intersections are and statements, and if that's the case, then both of them must be true, or else it's not true. So the next thing we're going to look at, we'll end this video here because we've done this demonstration of intervals, and we'll get into equations and inequalities next.